The title of today's lesson is Transformations of Graphs. So the first thing we need to do is learn about the 6 basic functions and their graphs, key points, and vertices. Our first basic function is a basic linear function. The parent function is f of x equals x. Notice there's no squared, there's no square root here. It's just a x variable with no exponents. This produces a straight line. And this function, y equals x, you can see here on the graph, it's got a vertex at 0, 0. It's got some key points at 1, 1, and negative 1, 1. And using our t-chart, we could find the values negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. Notice that my vertex is in the middle, and as well as my key points are right there. When you're doing these, the only ones you really need to memorize are your key points and your vertex. And once you have those 3 values memorized, we can transform these graphs a little bit later. Now this basic linear function, f of x equals x, we covered heavily in the linear functions lesson. And although it's one of our basic functions, we're pretty much going to be leaving this one to the methods that we used in the linear functions lesson. The other 5 you're definitely going to have to memorize. So let's look at the next one. Basic quadratic function, f of x equals x squared. Now this you can see is a U-shaped graph. We have some values here. Negative 2 squared is 4, negative 1 squared is 1, 0 squared, 1 squared is 1, 2 squared is 4. Notice that my vertex 0, 0 is right here, and my key points are 1, 1, and negative 1, 1. Those are right there. Again, the only ones that you have to memorize are your key points and your vertex. One way of memorizing this is you could just know that a quadratic, an x squared, is a U-shaped. You know the vertex, and to get to the key points, you go over the right one and up one, over to the left one and up one. And that's just another way you can think about finding those key points. Now we're going to be translating these functions. So just an example of a translated function, of a translated quadratic function, would be something like f of x equals 3x minus 2 squared plus 7. This is an example of a quadratic transformed function. Now we're going to be talking about how to translate this later on in the lesson, but I want you to see that we do have an f of x equals x squared. We have all these other values of adding 7 and minus 2 and multiplying by 3, and we'll talk about what each one of those do. But you need to be able to look at this and realize that this is a quadratic transformed function. It is f of x equals x squared, the parent function, transformed. Our next function is the basic square root function. The basic square root function is kind of like the parabola or the quadratic function we just talked about, laying on its side, and you only see half of it. So we're just going to say it's this shaped, a half of a parabola on its side shaped. To fill in our table, we have 0, 0. The square root of 1 is 1. And the square root of 2 is not a nice value here, neither is the square root of 3, but the square root of 4 is 2, and these go on, but this is sufficient. Notice that your vertex is at 0, 0, same vertex as the other 2. My key point, I only have a 1 key point this time, and the 1 key point is at 1, 1, and once you know those 2, and know the shape, you can figure out the rest of the graph just by knowing these key points and the vertex, and you can know the shape of the graph, and we can use that to help us transform. An example of a transformed square root function would be f of x is equal to 1/2 times the square root of x minus 1 plus 8. Again, notice that we have an f of x equals, we have the square root symbol, x. We have the square root of x. Notice we do have a minus 1, a plus 8, and a multiply by 1/2, which are all transformations, and we'll talk about that soon. But I want you to be able to look at this example and see that we do have a root function that has been transformed. One other thing to note, if you look at both the quadratic and the root function, notice that the t-chart with the x and y values on it are really just inversed. Instead of 0, 0, well, we have 0, 0. 1, 1, if you flip it around, is 1, 1. 2, 4, if you flip around, is 4, 2. If I continued on, 3 squared is 9. Also, in the square root function, we could have had 9. The square root of 9 is 3. That's just something interesting to note when you're trying to memorize what these shapes look like. It is the same values. The x and y values are interchanged, and we only have one branch of the parabola. The next function we're looking at is the absolute value function, which you can see from the graph looks like it's a V-shaped graph. To fill in its xy table, we have -2. The absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. The key points that you'll need to know are, first, you need to know the vertex. Again, that vertex is 0, 0. The key points that we need to know on this particular function is -1, 1, and 1, 1. One way to remember that is just to go right 1 and up 1, and left 1 and up 1, and make your V shape. Notice that these are the same key points as your quadratic function up here. But your quadratic function, you need to know, is U-shaped, and so it's going to be nice and curvy, and it's going to increase much quicker than your absolute value function here, which is V-shaped. It's two nice, very straight lines. So not only do you need to know your key points, you have to know the shape so you can graph correctly. An example of a transformed absolute value function would be f of x is equal to -2 times the absolute value of x minus 3 plus 12. I want you to be able to see that we have an f of x equals, you see the absolute value bars, and we're taking the absolute value bar of x. We do also have a minus 3 in here, a plus 12 on the outside, and a multiply by -2. Those are all transformations, but I want you to be able to look at this and see that its parent function is the absolute value graph. Our next function is the basic cube function. Taking a look at its graph, you can see that this basic cube function is what I might call an n-shaped. If your n was really stretched out, notice you have this little wiggle here, kind of like the middle of your n part. On our xy table, if I plug in -2, -2 cubed is -8, -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is +8. The values that you need to memorize are the vertex at 0, 0. Again, they all have been at 0, 0 so far. Our key points that you need to know are -1, -1, and +1, +1. And then you also need to know that it's a nice curvy n shape here, so that when we are graphing a cubic function, you can use these 3 points, the vertex and the 2 key points, to graph this shape accurately. An example of a transformation or transformed cubic function would be f of x is equal to 4 times the quantity x minus 1 cubed plus 3. Notice we have f of x equals, our x is being cubed. We do have a minus 1, a plus 3, and a multiply by 4, which are all transformations. But you have to be able to look at this and see that this is a cubic function because we do have an x value and we are cubing it. Our last basic function that we're going to be talking about today is the cube root function. The cube root function is what we might call S-shaped. Notice that the cube root and the cube function are basically the same values except one's laying on its side, so that means that the x and y values are actually interchanged. The cube root of negative 8 is negative 2. Notice that I'm getting this from the previous t-chart. The cube root of negative 1 is negative 1. The cube root of 0 is 0. The cube root of positive 1 is 1, and the cube root of positive 8 is 2. We don't do any values between 1 and 8 because I don't know the perfect cube of any value between 1 and 8. Or another way you could do that is just to take these values from x and y and interchange them. We'll be talking a little bit more about why that happens in some later sections. My vertex is 0, 0. My key points are negative 1, negative 1, and 1, 1. And I know that this is S-shaped. Using those three values, notice that they're the same three values on my cubic, but the shapes come out very differently. So you need to know that a cubic is more vertical N-shaped, and my cube root function is more horizontal or S-shaped because of the other values that we're not actually memorizing. And lastly, the example of a transformed cube root function would be f of x is equal to negative the cube root of x minus 5 plus 2. I hope you can see that we have an f of x here. We've got the cube root of x. We do have other values in there that are transforming and shifting and compressing and stretching, but on this particular problem, I want you to be able to, at least at this point, see that it does have a cube root as a parent function. Those are the 6 graphs that you need to memorize before we continue on and learn about our transformations.